afternoon, ladies and gentlemen. Welcome to this workshop about circular and sustainable building materials from and for Africa. My name is Wouter Moorlag, and I'm a cluster manager building innovation at the research organization TNO, and I'm very excited to be your host for today. In the meantime, I will give you a quick introduction on the circular building materials and why we're organizing this workshop. As you all know, the increasing demand for circular building materials is driven by a global resource scarcity and related increasing CO2 emissions. And it's simply more and more difficult to harvest resources. It literally costs more energy and more money, while at the same time, the demand is increasing. Population is rapidly expanding in Africa as well in Europe, and everybody would like to live in and work in a building that is safe and comfortable. But how to build these buildings when our resources are almost depleted? How to get out of this negative spiral? How do we go from a linear economy where valuable materials end up as landfill or get burned into a circular economy for a more efficient use of our existing materials? And what role can materials from renewable sources have? There are multiple strategies to go from a linear economy to a circular economy. And I notice that we often talk about recycling, but there are actually strategies that have a much higher impact. For example, smarter product design, use and manufacturing, extend the lifespan of building products, and a more useful high-end application of the existing materials. But also think about materials from renewable sources. And as TNO, we're active in all those fields. And I promise you, this was the only diagram that we would like to show you today, because the goal of this workshop is to move away from the theoretical part and the fundamental science and show you what can already be done. And therefore, I'm more than happy to have some of our greatest partners participating in this workshop from the Netherlands and from Africa, and they are working on a daily basis in their companies on these issues. So I welcome Kufrin from LEVS Architect, Ferrario, my colleague from TNO, and Mateusz Wielopolski from the Ethiopian-Dutch company African Bamboo. Very welcome. Before we start with the presentation of Thea, I quickly want to introduce TNO to you. Our mission as Applied Research Institute is to connect people and knowledge to create innovation that boosts companies and society in a sustainable way. And we do this in 4 roles. We develop fundamental knowledge, for example, together with research partners, CSIR, for example, from South Africa. We develop knowledge in public-private partnerships. So the projects that Ivan and Thea will show you are good examples of such a collaboration. We do contract research for individual clients. And a key part of our role and task is knowledge transfer. So we don't want to keep knowledge and innovation within our organization, but it should become available for companies, for organizations, and for governments all over the world. And that's why we always work together with local partners from the entire value chain in order to secure a successful implementation of the innovation. So if you are watching and are interested to participate in one of the projects or to work with TNO, please do not hesitate to contact me or anyone else of the team, since we are always looking for new, bright and enthusiastic partners, both from Africa and from Holland. So let's move to the first presentation. And to the audience, if you have any questions during the presentation for Thea or any other presenter, please post them in the chat. We will address them after the presentation and we'll try to answer as many as possible.
Good afternoon, everybody. My name is Kufrin, and today I will speak on behalf of LEVS Architects, where I work as an architect for a couple of years now. LEVS is an international office based in Amsterdam. We work mostly on large residential and mixed-use buildings, and we really specialize in local integration and sustainability. Most of our work is in the Netherlands, but also in Russia and in a couple of African countries, as you can see. Today, I will focus on our working philosophy through the example of a few of our projects in Africa. There we have realized many schools, especially in Mali, but currently we are focusing more and more on urban planning and housing, as we consider this an exceptionally important field in the future development of many African countries. So how did our work in Africa even start? Well, it all starts in Mali around 25 years ago when LEVS got involved in building schools in the Dogon area in central Mali. Today still we work with the foundation called Partners Pay Dogon as designers, but the foundation itself is busy with many more programs such as fighting desertification, providing water security, etc. Apart from this work with Partners Pay Dogon in the Dogon, we are also operating as a commercial office with different clients and in other countries as well. The land of the Dogon, where we have really learned so much, is characterized by a very harsh landscape and living conditions as well. So this is an environment where almost no resources are available, and it's really something that teaches you to work with what you've got. So it is here that we started our journey of discovering earth as a building material, as it's been used in traditional constructions for centuries. But this traditional way of building with earth has one downfall, which is that it's easily washed away by rain. For this reason, we started looking into possibilities of maybe reinterpreting this local technique in a bit more contemporary way. So together with the Dutch firm Oskam, we developed a hydraulic compressed earth block machine. It's a complete set of equipment, so a crusher and a mixer and a hydraulic press, and it's on wheels, so it can be transported from site to site. The block that you can see on the screen is a product that combines tradition and innovation. So it respects the old, but at the same time acknowledges the new possibilities. And now we often get asked by the clients, where can we buy a machine? And how fast can we build? And how cheap or expensive is it? Which is a very understandable question, but at the same time, it's a bit of a trap because just buying a machine is not enough. For us, the machine is just one part of the infrastructure of people and workflows that can actually sustain a lively built environment. So what is just as important as a machine is to create a local building culture that can develop and through time bring new ideas. For this reason, we have always been putting a lot of attention on training people by offering training programs on our building sites, but also by setting up institutions for technical education. In this regard, one of the most important recent developments was in Sanga, in the Dogon area that I've mentioned before, where we designed a practical training college. It's a college where students are trained to become farmers or electrical engineers or builders, so any jobs that are in growing demand in the region. And while the college is training students, at the same time, it is partly built by students themselves, so we do it in phases. The design of the school is inspired by layouts of traditional family plots in villages. We created several small clusters of buildings, such as classrooms or workshops or houses for the teachers. And everything is within a green walled area of 6 hectares. So in this way, the college kind of becomes like a new neighborhood in the area. Of course, life in the Dogon area is difficult. Without electricity or running water, many young people move to the capital, to Bamako, hoping to find a job over there. But as a result, if everybody goes to Bamako, then life in Bamako becomes very difficult as well. So many people who fled there face even worse living conditions than the ones they've left behind. So I would really like to emphasize that to achieve a certain balance and keep cities livable, it is just as important to invest in rural areas. Now I would like to move to a little bit more urban area with this other project. This is a project that we did for affordable housing in Celibabi in Mauritania. We started just over a year ago, and I think it's a great example of how bending the rules just a little bit from what is normally done, you can get as a result a much better life quality. Our client here was the Ministry of Habitat in Mauritania. We had already worked with them before, so they called us for an urgent assignment in the scope of completely relocating the city of Celibabi, because every year they have big floodings. We were invited to make a design and urban plan for the first 250 houses that would be built. And we decided to offer something a little bit different than this typical grid system that is nowadays being reproduced, unfortunately, all over Africa. And what we offered is a kind of compromise between the clarity of a grid and richness of a traditional organic settlement. We also introduced shared gardens, shared by a couple of households, to emphasize a feeling of shared ownership of the city. On the level of a household, we proposed just relocating the kitchen from the back to the front of the plot to create a better connection with the surroundings, with the street life. But also to give the possibility of using that room, for example, for a shop, as you can see here. So the few spaces that are there, we try to keep them flexible for the users. Making these kinds of innovations in design for any architect is great. But as I mentioned in the previous example, it's nothing without a local building culture. So in this specific project, we are very proud that we were able to activate a building site with more than 100 people involved in the realization. It is them who can continue doing other projects, so it's very important to keep the knowledge there. We have trained 2 teams to make blocks, with a member of our team on the site for almost 2 months. And there were members of the military and female builders and local trained masons, as well as students from a local technical school. So they were all there to follow a training program. And this program was led by Malian masons who were students themselves years ago and who were actually building the practical training college in Sanga that I've shown before. The building site is still ongoing. These pictures are a little bit old already, about 6 months, but by now many houses are already done, actually. A problem that we faced in all these projects that I've mentioned is that even though we built with earth blocks, with compressed earth blocks, there is always a small percentage of cement that we need to add to make the blocks water resistant. So the strength of the blocks is good, but they're still prone to water damage. For this reason, we teamed up with Oskam, who is producing the block machines, and with TNO, who have successfully implemented a different earth block in Malawi. Ivan will tell you more about it after my presentation. So we teamed up to make a research on how we could find another type of binder that is not cement and can be 100% locally and sustainably produced. We are currently doing this research in Senegal with our local partner Elementaire. And the project is subsidized by the Netherlands, by the RVO. Even though we are now focusing on Senegal, what we find there will be applicable to other countries as well, maybe with small variations depending on the availability of materials at any place. based on what we learned as LEVS with OSCAM, with our compressed earth blocks, and with this TNO block in Malawi, we are trying to make a new product that will be more sustainable, but also cheaper to produce. In our experience, cement, even if it's only 5% of the block material, it can be more than 80% of the price of the block. So finding this new binder that can really be local will make it much more affordable, and we hope that this can also help popularize the use of local materials in general. We traveled to Senegal to find these possible new binder substitutes. And we learned that there are not only potential primary resources available, but also waste resources, which is very important because we can help reduce waste from other industries. So we are currently examining the collected resources and making test blocks to verify the reactivity of the materials. And we are developing a machine that could heat some of the resources on relatively low heat, low temperatures, in order to develop the best possible binder. Within LEVS, we have tried to collect all that we've learned so far in the first tutorial book called Raw Earth as a Construction Material. What we hope to achieve is a very practical guide to our approach. So it is possible to order a copy if you would like by emailing this address. And here are just a couple of pages from the book. So we go from material handling and testing to load-bearing construction techniques and some examples from our own projects of different details that can be done with the blocks. To sum it all up, I would like to say that the use of local and sustainable materials is very important, but it is not much worth without a local building culture. And at the same time, good quality design that can help bring communities together. Thank you for your attention. I will stop sharing my screen now.
Super, Thea. Thanks a lot. Very inspiring. And I really like the integrated way that your guys are dealing with this. We had some technical difficulties. So to the presenters, I would like to ask you if you can please check again your VPN connection. They should be switched off. And in the meantime, I would like to ask the audience that if you have any questions, please feel free to post your questions in the chat. Maybe conscious of time, and then we can integrate the discussion on your topic, Thea, as well afterwards. Let's move on to the presentation of Ivan, which is also very closely connected to the part that you just presented. So please, Ivan, go ahead by start sharing your screen.
I will start sharing my screen. Good afternoon, everyone. I need to share my entire screen. So my name is Ivan Ferrario, and well, I work for TNO. I'm actually a little bit of an outsider in this community because I am an aerospace engineer, and maybe you would wonder what is an aerospace engineer doing here. I actually, in TNO, there is a program called Innovation for Development, which aim is to transfer technologies to developing countries and enabling these countries to continue the further use of this technology without being dependent on us, for example. And this project is an example of that because we started, so this program runs transversally to TNO. In TNO, we do multiple things, including space-related projects. And for me, it's a way to actually give back something to the community and to the society, because space is an interesting topic, but really dry. So the project that I'm working on right now is called Cold Ceramic Bricks. It's started in Malawi, And as Thea was mentioning, then it also spun into different directions into Senegal and other countries that we're working on. The problem that we are facing in Malawi is that there is a high demand of brick houses, like the one that you can see in this picture. We took a picture there because we went to Malawi actually beginning of this year. And the traditional brick making is done using wood that is burned, and in order to achieve the structural integrity of these bricks. But unfortunately, this has the effects of producing a lot of carbon emission, but also the quality of the final brick is not as high as it could be. And there is a very low yield. And the Ministry of Housing and Natural Resources decided that they wanted to shift and from this way of building houses to a more sustainable way of doing so. And they were looking to alternative technologies that could enable production of the same kind of house that people like, the red brick house, but without burning precious resources as forests. So we looked into a way to do that using local resources, and in particular waste streams and secondary streams resources. And we found a local entrepreneur. The name of this company is Terrastone. And we presented this possibility to this company that was immediately attracted by the idea of having a product that is more sustainable and at the same time is at least as expensive, if not cheaper than the traditional way of building bricks. So we actually signed a license agreement with them, and we started doing some tests and to produce these high-end bricks. So at the beginning of the year, actually, we went to Terrastone, and you can see some pictures here of what we've done in order to do some tests with the local resources. These technology that we developed is called cold ceramic bricks, and has been developed by TNO. It has a lot of advantages. Doesn't require firing or cement. Practically, you mix the recipe and the ingredients together, and they just harden because it's a chemical reaction. You can achieve a very high mechanical strength, meaning that you can build multi-story buildings. In theory, even up to 3, 4, 5 stories, but we're targeting 1 to 2 stories high as to begin with. We're using local resources that normally are a waste to combine it with the brick and reduce the price. And it's really easy to be produced, and it can be easily adapted to multiple local smaller entrepreneurs. So you can see also in the picture down here, you can see different results of bricks using different waste streams. So the idea behind this project was that we will start from a product for the high-end market, let's say for the most expensive houses. But in doing so, we will generate profits in Terrastone because the product that they can sell can produce some profits from there, even higher than the traditional brick. And then the profit of those bricks will be actually given back via license agreement and put back into a social brick fund, which is going to be locally managed. And the aim of the social brick fund is then to further develop this technology locally to reduce the cost again, but also to expand the amount of entrepreneurs, in particular the smaller entrepreneurs that locally could then produce their own bricks and their own houses. So that's the structure and the framework of the project that we set up. So we are right now at the beginning of this process, meaning that we've done these tests locally using local available materials and, of course, representative local conditions, because what we wanted to avoid, and we want to avoid, is that we come up with a nice recipe that works in a nice lab, and then in reality, in the real temperature and a humidity environment and the materials that are used, you find out that it doesn't work. So it really makes sense to collaborate from the very beginning with your partners locally. And unfortunately, this COVID situation stopped our plans a little bit because, well, we had to slow down our interaction in person, unfortunately, for a bit of time. So it's making things a little bit more complicated. As a bottom line, as a result, well, we are starting right now a project in collaboration with the GIZ and Terrastone, and this project is funded partially by Germany, Bundesministerie Zusammenarbeit in Germany. And what we're doing in these projects is exactly develop this recipe, test it in local conditions with the brick maker, and then start also the production of a lower end recipe for less expensive bricks, and at the same time establish already a supply chain and a pilot production of these bricks locally. And at the same time, we would like, of course, in our plans is to expand to different countries. And as Thea presented, of course, we are also invested in a similar kind of technology, although technologically slightly different, with Senegal, and with the ambition also to expand to Ghana and other countries. Thanks. I'll stop sharing it.
Super, Ivan. Thank you so much. Can you maybe explain to which extent the technology that is developed around the alternative binders is also available or applicable for other African countries? We already talked about Senegal, but to which extent can this be scaled up or extended to other countries?
Sure. So in particular, the technology we're using in Malawi and in Senegal are slightly different. So without going too much into the details, the one that we're using in Senegal can be very much independent of the local resources available. So that means that it's extremely flexible in terms of local conditions. So in theory, it could be transferred to any place, anywhere, and you could find definitely a mixture of local waste resources that could be combined to match the local requirements. The Senegal solution is slightly different, meaning that because it gets rid also of some components of the Malawian recipe that we are trying to get rid of, even to reach an even more local and more sustainable production, completely done locally, requires also that some materials are available locally and can be transformed. So it's still flexible, but a little bit less flexible. But what we've done in Senegal is that we made a survey of the local resources with local entrepreneurs that helped us in the process. And that could be done in other countries as well. So what we should do, for example, if another country is interested in this kind of technology, is to have a survey of the locally available technologies, materials and resources, find a suitable combination of these resources that is promising, do a quick test of what is possible to combine and what are the potential results achievable, and based on that, then tweak the recipe. And as Thea was saying, we are working in that project in the development of this machine that will actually provide more flexibility again in the recipes that you can come up with.
Thanks. And I was wondering, talking about the value chain, and to which extent other companies in Malawi, for example, architects or contractors, are also involved in this project, or is it going to be organized in the next phase?
It will be part of these social bricks fund scope of work. So at the beginning, we started with one specific company to be focused and to, as much as possible, be able to provide a product and enter into the market. The social brick fund, which goes on in parallel to this development of technology, exactly aims at providing smaller and hopefully much more companies, because that's the aim of the project, to enable a big scale production of this technology, in particular on smaller entrepreneurs. The way in which exactly this will be implemented is part of the projects that we are doing, because there are multiple ways of imagining a supply chain, a local supply chain that fulfill these needs. It could be, for example, that you can have some machines owned by a bigger company, and then like some sort of cooperative, and smaller entrepreneur can access to that, to the machines and to the materials that are needed to produce the bricks. Or it could also well be that separate entrepreneurs could own different production plants in a way. That depends on the local request, because what we wanted to avoid is that we come into a country and say, this is how you should do it. And actually part of the project is exactly getting in contact with the local entrepreneurs, and with them actually define which is the best strategy that fulfills this goal for them, with the local realities. And it could be different in Malawi, and it will be different in Malawi and in Senegal, for example. And we're going to work it out with the entrepreneurs themselves and the ministries as well.
Yeah. Maybe a question for the Thea. One of the projects that you showed was specifically organized around the market and the conditions in Senegal. As LEVS, I know that you're also active in different parts of Africa, for example, in Ghana. This morning there was a workshop on the circular economy in Ghana, also a part of this Digital African Business Days. What kind of opportunities do you see over there?
Well, actually, we don't have any projects in Ghana.
Oh, sorry.
But we would like to. For this specific research that we are doing in Senegal, the plan was to also do it in Ghana, and we were about to go there. We found local partners, but then it was around April, March. So because of Corona, it was not possible to travel there anymore to do the research, because it's really important to go on the field to have a bit of an idea of possible materials. So we are still hoping that in the future development, Ghana will be maybe the next on the list to try to implement this new technology.
Still in the pipeline, so to say. Very good. Yeah, this may be also for the audience interesting, because this morning we also spoke about the collaboration with African and Dutch companies in Ghana. So if you're interested, and also in Nigeria, by the way, so if you're interested and active over there, so active in the construction industry, architects or engineers or contractors, both from the countries, but also from the Netherlands, we're trying to set up a kind of a collaboration similar to what we're doing in Senegal and in Malawi. So if you want to join, please feel free to contact us, and then we can talk about how to organize this. I think it's time to move on to the next presentation. And I'm really happy that we also have an African, or at least partly African company here, because I think there's also a lot of potential from Africa that can actually be used in the Dutch construction industry. And also talking about a circular economy, to me, that's also very much related to renewable resources. Because why would we not simply grow our own resources in a sustainable way? And that's what can be done, for example, with bamboo. So I'm very happy to have Mateusz and Khalid here in the show. I'm not sure who of you will give the presentation, but please go ahead. And if you have any questions for the gentleman or for Tia, please feel free to post them in the chat. Please go ahead.
Hello, I will take over the presentation, but then we can jointly answer the questions when there will be more in the chat afterwards. Let's start with sharing the screen. All right. I hope you can see it now. Yes.
Yes, we can see it.
Okay, good. Well, my name is Mateusz Wielopolski, and I'm speaking today on behalf of African Bamboo, and I'm together here with the general manager from African Bamboo, Khalid, Duri. And as Wouter already introduced, we're going to be talking more about materials from renewable resources and especially local resources in Africa, and how they can create benefits and value beyond Africa, actually. And the resource that we're going to talk about today is bamboo. And African Bamboo, the company behind this, developed a proprietary technology in Ethiopia, which enables the development of sustainable construction materials and biofiber composite materials that can be utilized and help to actually transform the construction industry to a more sustainable industry with bio-based materials. Yeah, and we all know that because of the carbon footprint of the construction industry, there is a growing demand for more sustainable construction methods and more sustainable construction practices. And the shift to this more sustainable construction and sustainable built environment can be largely driven, of course, by material innovation, because using especially renewable sources that regrow as fast as bamboo does can dramatically help to reduce the CO2 emissions, which are one of the main factors for the energy intense conventional materials used nowadays. And then, in this sense, looking at Africa, what is nice about it is that it has a thriving habitat actually for bamboo, a resource which is used already since many years, and especially in China has been shown to be able to provide building and construction material for various applications, from non-structural to structural, from outdoor and indoor. And what African Bamboo is doing is basically injecting some high-tech know-how and innovation into a rather low-tech resource, or at least it is considered so far rather a low-tech resource as compared to tropical hardwood, for instance, and tries to capture actually this value in order to create impact on one hand locally, but of course innovating with materials, or innovating materials out of bamboo, which have an applicability in the construction sector, also has definite advantages and can be applied in global construction industry. So how does it work? So basically, African Bamboo has developed various processing technologies and that enable the processing of bamboo into different raw material modifications that can be afterwards manufactured into semi-finished goods and construction products, which offer, next to the benefits of a low carbon resource, of course also benefits in terms of mechanical properties that then can be applied in the construction. And African Bamboo captures this value by innovating technologies that in the end, as we see now, are relevant also for Europe. So what has been realized and what has seen is that there is a demand within Europe due to the shift to a greener construction. There is also a demand for such solutions in the Netherlands, for instance, as well, which is based on the growing focus on bio-based resources, also driven by EU policies and incentives, also driven by companies that put themselves CO2 targets to reduce their carbon footprint, and of course the growing eco-awareness of the consumers. So what African Bamboo has realized is, or the question that we were asking us is, how is it possible actually to create synergies with the technology that has been developed in Africa and in Ethiopia with using bamboo? How is it possible to create synergies and then enrich basically the regional construction environment, and not only enrich it in a way, but also develop region-specific solution with a future perspective together with the industry and research institutes. So African Bamboo can provide access to specialized expertise that has been developed in connection with the bamboo technology. But what is interesting about it, it can be transferred, of course, onto other natural fiber materials, which then can be used for the development of other material innovation for the construction business. So let me just start with why do we actually start with bamboo? So just to give you a bit of an idea about the technological potential, I wanted to show you the slide here. Wait, I cannot hear you. So sorry. So bamboo is bringing in a lot of advantages in terms of inherent material properties. It brings in flexibility in terms of the application scope, and like this, it can act as an innovation platform to scale up biofiber technologies for the whole building and construction sector. So what African Bamboo developed in the last 10 to 12 years is actually a processing technology that yields a whole portfolio of materials that can be obtained from processing bamboo in different forms, in different shapes, into high performance engineered products, into additives, into composites, and also into long fiber reinforcement for composite applications that can go into a high performance sector, like, for example, automotive or aerospace. Although, as you've seen before, it has the potential to actually go into various different markets, it's important to focus on one first application, and therefore we were looking into bio-based structural materials as an entry point because of the current demand of the industry, and also the current demand of or the growing demand of bio-based construction materials, not only in the Netherlands but also all over Europe. And once validated, this is something that this slide wants to deploy, is once this will be validated in the building and construction market, we see a potential to actually transfer the technology that has been developed for bamboo onto other natural fiber sources, and use it in a way that it can be processed into various bio-based inputs for various manufacturing processes that go into products such as panels and boards and beams for architecture, furniture, can go into natural reinforcement fabrics for sports and leisure, can go into composite parts for the marine industry or the automotive industry, but also as fillers into new bio-based polymers and so-called bamboo plastic composite materials. So how can we now create a collaboration potential with this basic technology input that can be transferred from Africa, where it creates value, and how can we now take this to create synergies in Europe to develop material technologies that have a sustainable future and that generate and create value also outside of Africa. And the idea behind it is to create a space for innovation in the end, where the government, the academic world, and the industry can work together and define a framework for innovations that can be easily and quickly transferred actually into applications. So the idea is to have to focus or bring in all this technology and focus it in a central R&D space where we bring all these players together from the industry, from the academia, and from the government, and create an eco space where fast knowledge transfer and real life projects lead to very quick applications of the technology. And one of the very concrete projects, the project that we are working on at the moment is displayed here, and it's this collaborative innovation center for advanced biomaterials, where we exactly want to show how this proprietary know-how on processing a bio-based resource can be transferred into commercial applications that for the building and construction industry, but which can also drive innovation by a very close collaboration together with the research institutes, with startups, with early adopters, early adopters of technologies. So let me finish with this slide here, which is displaying kind of the impacts that can be created by bio-based resources and sustainable circular thinking of how to use renewable resources and activate them in high performance applications, and on the other hand create a more sustainable built environment which has a positive impact on the environment. So with this, I would like to thank you And would like to finish sharing my screen. Yes.
Thanks, Mateusz. It was very clear and inspiring. Also, really happy to see that the bio-based building materials are also present in this workshop. And we have a question from the audience. Karin Kuipers is wondering, do you have an example of a product in Europe? And that was also my question. Can we already buy bamboo from your company? Or what's the status?
Well, it's good because it's good that you've seen the slides, because this was my problem. Now I couldn't see any of these slides, but I tried to go through it.
Oh, yes.
So you realize. Okay, good. We have over the last 10 years, there has been the developments which have been done with the companies, or actually the technology providers that I showed in the second but last slide. There is a backend of technology providers that were helping and supporting in the development, and were engaged actually in the technological development. This has been done in a way or under the assumption to have a certification for the European and then US and the US markets. So the products that were used, that were serving as a benchmark, were high performance bamboo panels and high performance bamboo decking and cladding materials that have been developed so far for the European and then US market as a proof of concept. But the idea behind it is to take this a bit further. This was a proof of concept that has been achieved at the moment, where there is a business model, a use case, and everything behind it. And the idea is to use and see where can we create actually the biggest impact on with these type of technologies. So that's the next step. So we're actually developing and looking into developing new products for the European market.
Yeah, and that maybe also relates to the second part of Karin's question. Which kind of parties are interested in the materials? Because that would also be my question. I think it's very interesting what you presented on this collaborative innovation center for advanced biomaterials, as you call it. But what are the type of companies that you are looking for that could participate in this what you call bio alley? Is it only in the construction industry, or could it be broader?
Well, we see definitely a big impact and a demand from the construction industry. That's where we see a big impact in the building and construction sector that can be created by solving, first of all, the problem of having very energy intense material technologies, especially in structural applications. So I think that's something that is a straightforward way to go in the next steps. But of course, as I've shown before, there is a wide flexibility and broad range of using bamboo as a feedstock for other manufacturing processes. And there has been applications developed already for which show that it is feasible to replace glass fiber, thermoset composite materials, and then produce household goods, structural household goods, or sports and leisure products, for instance. So the BioAlley concept is meant to create actually those synergies and be open to develop focusing on high-tech applications, be open to showcase the potential that actually biofibers can achieve in other high-performance sectors, which is still undervalued. And of course, also the construction industry is a very difficult case to get in. But on the other hand, this is why we're looking into it. It is one with the highest leverage, actually.
Clear. So if people that are watching or companies, organizations would like to join the BioLA, they can contact you, I suppose? Yes, super. Okay. I think we're almost there. A couple of minutes left. I want to thank all the speakers for the presentations. The presentations can be found after this session in the part called Documents. So we will upload the presentation, so they will be available for everyone. There was a question if this session is recorded. I'm not sure. So I will ask the organization, and maybe they can share a link afterwards. I see a question for African bamboo from Robert van der Hum. We still have a couple of minutes, so let's just go to the question. How do the Chinese utilize bamboo for such huge value? Which products is Robert asking? So,
in China, it has been started very early, actually, to try to industrialize the processing of bamboo, and the value capture has been also recognized very early. I think the main point is that in other countries it's still a low tech resource, so it's not super sexy to work and develop bamboo products. It's more, and on the other hand, in European countries, in America, it became a sexy product because of the environmental conscious. But on the other hand, there was no resource. And the Chinese realized very quickly that if you have the resource and you start industrializing the processes, because it's a difficult resource also to handle. It's not like timber, because it's hollow inside, so it's simply the processing is already difficult, and that's how they started to develop products for building and construction, and that's something. What's the next step to bring this further is definitely a standardization of regulatory frameworks, but also of the manufacturing methods. And this one is more advanced in China already.
Yeah, that's the biggest difference. Yeah, thanks. Thank you all. It's exactly 3 o'clock, so I would like to close this session. To the audience, thank you very much for watching. If you have any questions left or want to contact me or one of the speakers, please feel free to send me an email, wouter.moorlag@tno.nl, and hopefully see you soon somewhere else on this globe. Thank you so much and have a nice afternoon. Take care. Bye-bye.
Take care. Bye. Thank you.
Thank you.
Speakers also, thank you so much for participating.